So we're going to be talking about working with documents, how to link between documents, and then in the next session we'll talk about how to build secondary indexes and run queries. But for now we're just going to talk about working with documents. And for me, Couchbase Server 2.0 is new. I mean, it's not just an optimization of some pre-existing technology, and so the ways that you work with it are new too. We're still figuring this out along with our users. But Jazip had a great introduction because he specifically stayed with sort of the key value interactions, and I'll talk about why we want to focus so much on that in a few slides. So what are we going to do in this talk? We'll talk more about JSON documents. Hopefully it won't feel like too much overlap from the last talk. It's sort of a different perspective, but the same topic. Then we're going to look at some runtime-driven patterns for interacting with those documents and linking between them, how to safely, use CAS, and how to interact with large groups of documents. And then at the end, I'll scare you a little bit about what happens when we get into the multi-Datacenter world with eventual consistency, but just enough to get you thinking. So JSON documents, these are all, it's a well-known pattern, right? In computer science, you've heard about aggregates, and if you're in Java or whatever language you're in, you have a class hierarchy, and you maybe have your main object, your invoice, and it's made of these 10 other classes, and some of those classes are, also aggregates of other objects. And when you get down to the bottom of it, typically the data gets turned into a tabular format and put into a relational database. And so this whole mess, what those arrows are, that's your object relational mapper in the traditional, in the traditional world. So with a document database, you just work with that aggregate as a whole. And if you want to split it up, you split it up because you want to, not because you're trying to get it to the fourth normal form or something. So a couple of points worth making about document databases. First is that from a technical standpoint, because they're essentially a key value store that can see inside the data and offer queryability, they can scale. It's less of an uphill battle to make a document database be large scale and high performance. And then the flip side of working with these aggregates is that it looks more like what's in your code. It's application developers are kind of have less hoops to jump through to work with it. So sort of the way I like to think about this when comparing the relational database and the document database is that with the relational database, you'll spend the first few days of a big project on the whiteboard drawing up all this UML and relationships and foreign keys and constraints, and all of that is concerned with the format of the data at rest. So when the data is no longer moving, when it's frozen, what does it look like? With a document database, you're going to be a lot more interested in the runtime considerations. Do I have 100,000 of these a second coming in? Do I have to run a background process that turns these into these? It's much more of a runtime oriented decision making that you're going to be going through rather than trying to build a model in a relational database that always hews to some sense of correctness. So JSON has your simple data types. I'm not going to intro JSON to y'all, but just the basics for Couchbase for people who were not in the previous session. You're able to save these objects, these serialized text objects with your basic types in them, and they live underneath a document identifier key. So that key is unique. You can use it to do a uniqueness constraint. If you made it social security numbers, you'd only get one document for each. It's up to you how you want to find those identifiers. So a lot of the patterns that Jazip talked about in the last session were, I've got an identifier, let's go use it to load a document, find some more identifiers, or derive some identifiers and load them. And that's essentially what we're going to show in this session too, but I'm going to motivate it a little bit from the performance considerations. So here let's look a little more deeply at a document. This is showing some of the stuff that was left implicit in the previous session. So the green part on the top is user data. That's completely under the control of the developer. You can put anything you want in there. So some of the other JSON-based NoSQL databases have rules about what can go in the document. Our rule is it just has to be JSON. You can import a bunch of data with underscore rev fields if you want, and it'll accept it happily, but to Couchbase, it's just data. And so there's no special prefixes or special fields in the document. Then we also have essentially a shadow document, which is the metadata that accompanies the main document. And there's more to the metadata than just the identifier, but it's all that sort of stuff. So if the document has an expiry time, which you can set when you create documents, you can say, delete this document at this time. If the document has flags that you can set via the SDKs or there's the CAS value for doing document saving. That's the kind of stuff that shows up in the metadata. So this is essentially stuff that's not under the user control, but is kind of handy sometimes. And we give you access to that inside the MapReduce query engine, which I'll talk about in the next session. But I wanted to bring it up here so you get a sense that there's more than just this. If you're looking at this and wondering where the identifier was, well, it's here. One of the other things on this slide that's just a good illustration is this vintage date format from an old SQL dump. This is the first one of these little bits of kind of ugly legacy data that you're going to see today. But that's a really common sort of workload or problem that people use NoSQL to solve. And I'll talk more about that later, but when you're ingesting this data, you often aren't in the position to clean it up and normalize the timestamp format and all that as you're saving it. So there's a bunch of strategies that we'll talk about in the next session about how you would deal with these sort of varying date formats, and so you can relax on the ingest side and then still be able to query it later. So the big benefit that we hear developers talking about, we like to go around and talk about how we're fast and we scale, and because that's fun to talk about, but the developers out there who use NoSQL and use Couchbase and tell us their feedback, what they like about it, they like that they don't have to all sit around and say who just pushed a new migration, what version is the database on. There's not a global innovation lock around your development team when people can just add new fields to the JSON. So again, I kind of want to split up what we're talking about in this talk and in the next talk. So I'm not going to talk about views, but we will talk about the considerations that go into your schema. And then later, as we query it via the MapReduce engine, that's when I'll talk about emergent schema and how you can make sense of the data after the fact. So this session is really about working with data on the hot interactive path when you have users who are going to be more engaged because they got the response back in 5 milliseconds instead of 50 milliseconds. And so when you're in that kind of user-driven experience, performance really matters. I'm not going to dwell on that here, but it's worth it to write your code a little differently to be faster. Your users will thank you. So as I said a few times already, your schema, your data structures, they're going to be driven much more by runtime considerations than they are by data at rest considerations. So let's talk about that live data and how you're going to interact with it in Couchbase. So again, this talk, I'm really trying to narrow the topic so that we're talking about the super high performance path that you can use to give the best user experience. So this is a Couchbase architecture. It's not up here so you can look at all of it and understand it all. I just put that orange box around a little tiny bit of it up in the top. That's the part we're talking about in this talk. It's just that memcached binary protocol for gets and sets and multi-gets and CAS operations that has the consistent sub-millisecond latency. And so everything else is sort of there to support that, but you don't need to worry about what's happening on the disk for the most part when you're interacting with these data structures. You just want to know, has the database got my data? So with this runtime-driven schema, the first thing that is a breath of fresh air is that what's in the database looks like what's in your code. If you've built up an object, then you can just save it, and that's a lot less head scratching you have to do next time you come back to that code and try and ask yourself what is it supposed to be doing. And then again, it's the runtime considerations. So you'll look at your app and you'll say, I've got these 3 user stories that I'm trying to build for, and this is the user story where performance matters. This is the manager or something. Like if they have to wait, that's not great, but it's we really need to tune for the end user. In another case, it might be the manager is driving the performance requirements, and so you'd think about a different path through your application as being the hot path that you want to optimize. So in general, you end up in this world where data flows are going to be sort of taking up proportionally more of your mind share than data at rest. But I think that's the world we're living in. When I ask developers, what does a project look like? I feel like the new normal for a development project is get the Twitter API and the Facebook API and dump them in somewhere and make sense of it to pull out some business intelligence. And if it's not those APIs, it's some other unstructured or semi-structured data stream that you're going to be mashing up with some other stuff. And trying to figure out exactly how that's going to look when it's at rest is just a waste of time. You want to think about the data flows, not the data structures at rest. So that's not to say there's no schema. What it is we've wandered into a world where the database doesn't care about the schema. The database can handle it. So now the application is going to drive the schema. And when the application is driving the schema, it's a couple of the same questions that Jasdeep raised. Right? When should I deal with a big document versus when should I have lots of small documents? And that's kind of the main question. I mean, there's some nuance there and different ways of linking between them. But the big question is, do I have one large document? There's going to be some advantages there. You're going to each document by itself is transactional as far as being saved. You can observe it and know when it's made it to disk and be replicated and all that. So if you really need those kind of semantics, you may have to have a big document. But on the other hand, a big document, if lots of users all want to touch it, maybe you want to split it up, and then the users are all touching sub-documents that are sort of related, and then your job at the runtime becomes, how do I work with these related documents together? So there's sort of 2 smells that you can use to guide yourself when you're doing this. If a document is just going to grow without bound forever, that's a bad smell and you want to avoid it. So in that blog post example with the comments, if you inject the full comment into the blog post every time somebody writes one, that blog post is essentially going to grow forever if there's enough comments. Having the comment IDs in there, it's maybe the same problem if you get really abstract, but it's not going to get that big even if there's thousands of IDs. So documents that grow without bound are bad. We'll look at some patterns in the next session for how you can use views to roll up a whole bunch of little documents to give you sort of these virtual aggregate documents. And so we're going to be hewing a little bit closer to considering whether or not a document is a standalone entity and how to link between documents in this session. So at the other end, you don't want to over-normalize. When I'm working with a relational database, on applications that use that, I'll write all the code and get it deployed and everything's good, and I go do something else for a couple months, and then I come back and it's time to add a feature, and it takes like a whole afternoon of me staring at the schema and the queries that I've been running and all that just to bootstrap in my mind, what does the application even do here? And so if your documents are self-describing, they don't have to be like 100% self-describing, but if you can look at the document and you go, oh yeah, this does that, and look at this other document, and it's going to cut down on that time of understanding, reading the code and getting yourself back into a project. So let's link between some documents. This is going to look familiar for people who were in the previous session. So the challenge here is we have a bunch of documents about beer, and we want to put some comments on there, but we also want to rate the documents. So this gives us a way to look at a couple of different ways to interact with these documents in the same context here. So the challenge is linking between these documents, embedding the ratings inside the documents, all under sort of a system where there's no transactionality between documents. So we want to, the pattern we're going to do here is we're going to put the comments on their own document, and then link back to the comments from the beer like we saw in the previous session. But then we will also inject the ratings directly into the beer document. And so that'll give us a couple different ways to do it. So here's what it looks like. I give that a 5, right? That turns into this, this hash of ratings you can see down on the bottom of the green square there. For people in the back, I'll describe it. It's curly braces and then key value pairs where the values are ratings like 5 and 3 and 4. And the keys are user IDs like jChris. And so if you have a mapping from user ID to rating on that beer document, well, now the problem of a user rating the same beer twice goes away. The data model itself constrains you to 1 rating per user. So then what you'll need to use CAS, and we'll talk about that in a minute, to make sure that the users aren't erasing each other's ratings by accident because it's a shared data structure. So now let's look at the comments for a second. We're going to save the comment, which is essentially just running the set command with a given ID. Here we're using a completely random ID and throwing some JSON at it. So user number 525 says it tastes like college. And now once that's saved, we have the associated metadata that's going to be used for the lookup. And it's time to link to the beer from the comment. So here we have below the ratings in that same beer document an array of comment IDs. And you see we also have a link back to the beer ID on the comment itself. So you'll see in the next session how you could build a map index to query the comments by that about ID field. But again, that high performance path, even like let's say you had to go load 10 comments, and we'll do that in a second in the next slide, it's going to be much faster to use this system than it will be to use the MapReduce. So it's just sort of, MapReduce is disk based, and this is all based in memory, so it's orders of magnitude different type of performance. So how are we going to get from a beer to all its comments? We have some options. Again, I mentioned, and I won't talk about it in detail, you could use a view, but if you're in this really high performance runtime situation, either of these other two options are going to be much faster. So the difference between the serialized loop and the fast multi-key lookup is almost academic, but it's a good way to illustrate some differences. So in the serialized loop, you've got the list of comment IDs associated with the beer. You're going to take that first comment ID and do a get and get that object back and deserialize it. And then you're going to do it again for the second comment ID and for the third and the fourth and so on. And so what that means is that, assuming your code is super fast and your network, and Couchbase is acting properly, all that's really fast, and it's kind of not that different from what I've enclosed in the green bubble here. But the green version gives Couchbase the opportunity, working with the smart clients, to do a bunch of work in parallel. And so it's just as easy for you from a writing code perspective, but as that list of comments grows from 5 to 500, it's going to be much more resilient in terms of maintaining high performance. So now let's talk about adding that rating. And we talked about CAS. You sort of heard of CAS in the previous discussion. Here we're going to use it. So CAS stands for compare and swap or check and set. Essentially, it says, I only want to update this item if the thing sitting in the database is the same as the one I loaded, when I first loaded the item. So if you have a beer that has 3 ratings on it and you're going to add your rating, you load the beer. It's got this CAS as part of that metadata document associated with it. And when you go to save the beer back with your rating associated with it, you include the CAS, and your operation is a type that fails if there's a CAS mismatch. So if anybody else beat you to it, somebody else's rating, and they loaded it from the application server and got it saved back before the code that's servicing your request got the job done, it would fail, right, and allow your code to reload it and retry and save it back where nobody's rating gets lost. And this is a really key feature for anyone who wants to build any kind of rigorous data, a database or query, kind of on top of Couchbase. If you're using a NoSQL database as essentially a block store for some higher level abstraction, you can't do it without a CAS primitive. So it's handy, and you can do a lot of more basic stuff too. So what we're showing here specifically in code is kind of a Rubyism of, let's take a block that is the operational transform we want to do on that document. And so by defining our work in terms of this operational transform, it gives the client SDKs the ability to run retries for you if there's a CAS failure. It's not always appropriate to run a retry, and that feature is also not available in every single language we support. You may have to do the retries by hand, but the general approach is, if your unit of work is independent enough, then you may have to retry a few times if the document is popular with other people also trying to update it at the same time. But eventually you'll succeed and no one will have lost any data. So that beer and comments is kind of a toy. It's the tip of the iceberg for any application, and what it will turn into quickly is, here's your just down in one little corner would be your whole beer and comments zone, and you've got your your main course and dessert, and am I going to have steak or lamb chops or apple pie, and then over here is all the beers, and so in a real application you end up with all these different universes, and they may intersect differently for different users. So I like this example of a dinner, because you can imagine, put yourself in the shoes of the chef who's wants to make a bulk operation update across the entire the entire thing to list a new ingredient that they're putting in all the food or something, right? And that's going to be completely different in terms of the performance requirements from a waiter who is trying to put in orders as fast as they can, and that's going to be different from the line chef who has to say, oh, we're out of eggplant, so these 4 items are no longer available. So you kind of need to come to those use cases from the user's perspective. And one of the tools that we have to to facilitate that is some fine-grained locking. And so it's not safe. That's why I have Evel Knievel up there. But it allows you to do some things that would be hard to do otherwise. So get with lock is a command that when you run it, it essentially primes the keys that you read to say no one can update them in the next 30 seconds unless it's a CAS update. And so then as long as and it's your CAS update, right? Because you did the get with lock that set the CAS where it is. So as long as your app server doesn't crash or disappear or something, it owns those objects for write purposes until the lock is released automatically after 30 seconds. So there are safe ways to work with locks, and there's unsafe ways. And a lot of the fun is the unsafe stuff where you're just like, I'm gonna lock all of dessert and update it and hope for the best. But the safe ways are sort of more fun from a computer science rigorous standpoint. So that's part of why they're dangerous, right? If the way to be safe with the locks is to treat them as advisory. And so if you have code that can 100% recover from, like, let's say you get with lock this whole graph, and then you go start updating it, and it all works except for like the second to last one you were going to update. Somebody else beat you to the CAS there for whatever reason, or like it happened in another data center and it replicated in via the back. If your code can handle that situation, like let's say doing the update costs a penny and handling that situation costs $1, then using Git with lock is one way to spend $1 less often, right? It'll just kind of, it's advisory, but if you know what to do in the case where the locks, don't do what you were hoping for, then you're safe. It's when you think the lock is always going to succeed that you can get yourself in trouble, because it's not a transaction, it's just advisory. It says, I'm planning on doing something with these keys. So yeah, there's a lot of sort of tricks to doing more transactional type work on top of a document database that I won't talk about here. I mean, it's all like two-phase commit and kind of rolling your own transaction boundaries and stuff. And so if you're really serious about transactions, then I would almost, and rolling your own transactional support with that sort of two-phase commit stuff, Git with lock is a nice little optimization to have in your pocket. Like, oh, I've already got all this two-phase commit working. I'm getting a lot of chatter here that ends up throwing exceptions, and if I had just locked it, it would be different. That's the right place to use it, where it's safe, when it's essentially an optimization. So, multi-data center consistency. I don't think that there's any way to get consistency worldwide and support the availability that our users need. Certainly that's not what we're shooting for with our cross data center replication. So if you've got 3 data centers, the replication lag may be a few seconds between them. The locks just don't work like that. That's not, setting a lock here isn't going to set the lock here, and you probably wouldn't want it to. So if you're using any of those counter patterns, or depending on counters in Couchbase to give you, monotonically increasing sequences, you're going to need to prefix that counter ID, right, with the data center name. So if you have a counter that is, today it's called my next user ID is, and that's the name of your key, and it's 1 now, and it's 2, and it's 3, and that's the IDs you're handing out to people. If you move into this world, then you're going to have 3 keys. My next US user ID is, my next Asia user ID is, my next Europe user ID is, and so on as you scale up. So it's a little bit of a leaky abstraction, but that's what we had to do to offer you things like atomic counters. And it's CAS is similar. You're going to be able to know that you owned the updates in your data center, but it's up to the conflict resolution algorithm what's going to happen in terms of updates happening in other data centers and streaming in via the replication stream. So typically our users have data center affinity anyway. You've got a data center with a cluster in it and your application servers, and as long as your users are pinned to a set of application servers, then most of these problems go away. But you can see also sort of at the logical extreme, if you push these all the way out, where like maybe you have a variable number of data centers, you don't know how many data centers you're going to have. Then these patterns, having incrementing counters and trying to do natural keys in your IDs for uniqueness constraints, all that becomes much more problematic, and your life may be simpler. JSON, we're going to be talking, well, we talked about JSON documents in this runtime-driven schema business. The next session, I think after lunch, this is going to be me as well, and we'll talk about MapReduce and views and some practical patterns for that. So yeah, if anybody has any questions, we've got about 5 minutes left in the session. Yeah. So the question is, and maybe, although I don't address it in the views talk, but there'll probably be people there who really want that answer. So the question was about chained MapReduce, and if you really want to hear the answer to that, stick around for the next one. Yeah. On topic with what I've just been talking about, the biggest difference between Couchbase and CouchDB is that CouchDB has those reserved field names inside of documents like _ID, _rev, other underscore fields. There's none of that in Couchbase. It's all user data. So from a data model perspective, that's the big difference. But really, as we're talking about here with all these, you're going to run different schemas on Couchbase than you would on CouchDB, because your schema is going to be built for these high performance key value interactions where you're loading a document and then using multi-git to load some other documents, and then those documents may all have 1,000 keys, and you run another 1,000 key multi-git, and then you draw your API response for your user or something. In CouchDB, you just wouldn't do that. The latencies would add up, and it would not be fun for your user, but it's the best way to work with Couchbase. So they are quite different in that regard, even though from a JSON perspective, they're pretty similar. Other questions? Yes. So the question is about the difference between the Couchbase buckets and the Memcache buckets. So the Memcache buckets we have are essentially just Memcache. Most of these operations are there. I don't think get with lock is there. But Kaz is a Memcache, and Inker and Decker, those are all Memcache primitives. So those are available. Typically, even users who are using, mostly just for caching workloads, a lot of them will run with the Couchbase bucket anyway, because it gives you some more assurances about, how much downtime or cache misses you're likely to see when you add or remove nodes. The rebalance magic doesn't happen in Memcache land, it's just on the Couchbase buckets. Right, yeah, if you don't need persistence, then you're paying a cost for persistence that's essentially only benefiting you during a rebalance. Other questions? Yes. So the question is there a limit to the number of documents you can fetch with a multi-git? And I'd say the answer is effectively no. I'm not sure what the actual on the wire thing that's going to happen there is, but the SDKs are, so first of all, like let's say you're getting 1,000 documents. Well, you have 10 servers in your cluster. Well, you're really only getting 10 documents-ish from each server. So you'd have to have a whole lot to get all at once, where it would really be any amount of tons of work for a given server. Other questions? Yes. Oh, so the question is about a updated timestamp. And no, we don't do any timestamping in meta, except for the expiration stuff. And so I suppose you could use that for something, but generally you're just going to want to use your app layer to stick timestamps in your document. So we are, maybe we have time for one question, but I want to make sure and cover the demo information again that I just got. So we've got demos all afternoon in the lounge, and I'm just going to go through the times so if something pops out that you want to see. The first one is Couchbase Labs, so if you like the language Go, if you're interested in that Elasticsearch stuff we were talking about earlier with full text integration, that's at 1:15 in the lounge. If you want to talk to people working on the internals of the Java client libraries, that's at 2 o'clock in the lounge. For .NET, that'll be at 3 o'clock. For Ruby, that'll be at 3:45 in the lounge. And then for PHP, that'll be at 4:30. So if you need to, find the right person to talk about that patch you've been working on, they'll be there. So thank you very much.
Nice job.
Thanks.